Hello and welcome to another video. Today I am going to talk about the coronavirus, so this is not my expertise. I am not a medical professional. I am not a professional in the infectious disease field. I am a chemistry major. This is my research topic is on physical chemistry, so I am good with numbers, but I don't really know anything else. But I want to take a look at the numbers. So why I chose to talk about this topic is because recently I've been talking to a few of my friends, and people tend to be either very dismissive of this disease, of this epidemic, or they are like total doomsday preppers, buying up all the food supplies and the toilet paper and stuff. And so I would like to urge everyone to be very careful in their attitudes, and so don't overdo stuff, but always do the logical precautions, the reasonable precautions. So most people who are dismissive about this virus are just citing this coronavirus death rate. They say like, oh, the overall death rate is like 3 point something percent, and well, it mostly affects like old people and people who have pre-existing medical conditions like cardiovascular disease. Like you can see, it's quite high, 13%. Diabetes, chronic respiratory disease, hypertension is also critical factor, cancer. So I think it is good to think about it, that if you catch this disease at the age of 70 and you die, this disease probably robbed you of a decade of life. And like cardiovascular disease cannot kill you that fast as the coronavirus. So this disease, even though you are maybe in your 30s or 20s and you are like, yeah, I am not really affected, and the people who will die would probably just die anyways. No, this is not really a compassionate attitude. And also, you know, maybe you won't die, but if you need to spend 2 weeks in a hospital with a pneumonia, that won't be fun. I spent 1 week in a hospital with pneumonia last summer, and I can tell you it's not fun. You don't want to do this. And so of course the other problems is that so this is from a medical journal, so this is kind of as a good source as you can get. And so what is the problem here is that, well, severe cases 14%, critical cases 5%. So even if you don't die, you can still have a very bad time in the hospital. So I think we have to consider this virus seriously, even if the death rate, like the 2% death rate, seems to be low. So what I want to talk about is, so I am, of course, my research is a chemistry, so I am looking at all this through the lens of a chemist. And so in the chemical reactions we have what we have molecules like this A, B and C, which may be dispersed in a gas or like a solution, and they react to each other. And in this case we got like the B moves to the C here, so we got the A and the BC as a product. And so these molecules basically colliding randomly. And so I look at the humans like moving around randomly and meeting each other randomly. And for the chemical reactions, we can write down the rate of the reaction as basically based on this is concentration. So these square brackets mean the concentration of each compound. So the more we have from the AB, the higher chance we have that this C got bumped into it, and so the reaction will proceed. And of course, the more we have from this C, this will speed up the reaction. And there is this kind of constant that will basically describe how many of these collisions will be successful. And so if we look at the processes what happen in a virus, case. So we have humans, healthy and sick people. They meet, like the molecules would meet in a chemical reaction. So two humans meet, and so the sick people stay sick, but the healthy people becomes infected. And so we can describe this like with this delta symbol. The Greek delta letter will tell us the change in the number of the infected people. We can write down this similarly for that we did for the chemical reaction, like the number of the healthy people, the number of the sick people, and some kind of other number multiplied with it. And then, so of course, from the coronavirus, we also know that people who are not sick but only infected can also infect people. So the number of the infected people will also increase with this formula, and so we can just maybe try to add up that we got this formula in the end. And so we can see that the increase in the infected people will be dependent on the number of the infected people and the number of the sick people, and also the number of the healthy people. So there are also processes like the infected get sick, and infected people can also just recover and become healthy again, or the sick people can recover and become healthy again, or the infected or the sick people can just die. And so this kind of processes can also have this kind of the rate of the people becoming sick from infected can be written down like this, and so the other cases have similar, but we don't really need to care about this. So we really have to care about this, because this is how we increase the number of infected people. And so the number of the healthy people is practically constant. So let's take a look at maybe, China has 1 billion people, and there is like 80,000 of them got sick or infected, and so the remaining is still almost 1 billion. So we can consider the number of healthy people as a constant in this case. And so these numbers, which will describe the so these will be like some constant which is dependent on number of contact between people and personal hygiene. So if you shake hands with everyone, then of course you will have a higher chance to get the infection. So what can we say about this is that let's take a look at this drawing. So what can we do? So maybe we have this is our society here, and so someone is suddenly infected. So maybe he went to China, came back with the infection, and moved around a little and infected a few other people. So what happens is that some other people in this society will become sick, so the number of the sick people will increase. And so, of course, this person, sooner or later, he will get sick. And so what is the kind of the early stages of the disease, what is happening in a lot of European countries now, and what has been happening in Asian countries like Taiwan and South Korea for a while, is that when these people get sick, they test him. He got the virus, so he is put into quarantine, and then they try to figure out who did he meet. So maybe this is his wife, so they put the wife into quarantine too, and then they find this guy too. So this is kind of discovering the previous contacts. And so if you do that, the people in the quarantine are not in interaction with society anymore. So if like we remove them from society, so if we can keep the sick people especially in the quarantine, we can put them then, so this sick people in the society, this will basically can be considered as zero. So only the infected people who did not get discovered will spread the infection more. And so this is what the risk is. So maybe before this guy is put into quarantine, he already infected a few of his peers. And so we put him in quarantine, but it's already too late. But maybe someone else, gets sick, and then they figure out, or maybe they can just trace back this person's contact. And so what is been going on for a long time in Korea, for example, is just trying to remove these people from the society in general. So always like this person can get so just a low number of other people infected. So the case number is just increasing very slowly. Like in this graph, if we take a look at this graph, so this is from March 12th, and we can see that up until this point here, the number of cases in Korea was very low. This was the turning point when it started getting higher. And so what happened at that point is that there was some religious group whose I think some of those went to Wuhan, so like the center of the whole epidemic. And so these two guys, they started to infect other people in the religious group. And so and one person got sick and did not get quarantined and did not go to the hospital to get tested, but went to the church service like I think twice before testing for the coronavirus. So of course the number of cases got really high. By the time this person got into the quarantine, we had too many people. So, and these people were also, mingling with friends and workplace and other. So there were more and more infections, which you can see here as the number starts go up, and it goes up until this point, and after this point this increase starts to slow down because lockdown was implemented, so people were staying at home, events were cancelled. So a lot of people, so the number of the people meeting each other, not this, sorry, what am I doing? Okay, so the number of people meeting each other got decreased. So this factor, so we can basically simplify things to this point. So the number of the infected people basically depend on the factor and the number of the infected people out there. And so we try to decrease this factor to decrease the number of infections. And so if we take a look at this figure here, this equation, then how do I, yeah, okay, so if we take a look at this equation here, this is very similar to what we got for compound interest. And so compound interest, let's is like or like, let's say it's a bank, it's money in the bank. So let's say you have $100 in the bank, and if you have like a 0.1 you have a 1% interest rate on it, then this is how your money will increase in time. So let's take a look at how your money increases. Here I will decrease, minimum value should be 0. So this is what happens to your money for 30 years if you have this interest rate. What if you have a higher interest rate? Then of course your money will increase much faster. So this equation is basically based on these facts. So in every year, for the case of your bank deposit, so every year the extra money you get depends on the factor, which is the interest rate, and also depends on the amount of money you already have in the bank. So of course the more money you have in the bank, the higher the interest you get. will be. And so of course a higher interest rate is much better, and the same is true for this sickness. So let's remove these from here. And so let's say for like maybe there is only 20 people sick in the country, but everyone infects one additional person, maybe let's say just every 5 days. Let's say every 5 days you infect a new person if you are infected. And so you get this very nice graph of 30 days. In 30 days, if this happens, it goes up until almost 5,000. So what if we can, cancel events and people will meet less, so you only infect a new person every 10 days. And so this is a huge difference. So you can see that just halving down the exposure to other people. So this is why canceling public gatherings or canceling school, canceling class. So for example, university, especially university classes, you take every class, you meet other people, and so one day you meet maybe 100 people. Class is cancelled. That decreases the number of people meeting a lot, and you can see that this is very, very important. So let's just add one more graph here, so you can see. Oh, you cannot see the bottom. So this is how these three graphs look like. So if you can decrease this number here of the rate of the infection, like how often do you increase, how often do you infect other people if you are sick. You can decrease that by decreasing the number of people you meet, and of course by increasing your personal hygiene, like washing your hands often and washing your hands properly, disinfecting things at your home that you touch often, like your keyboard, your phone. You wear masks. People wear masks if they think they will cough, because even if you don't feel sick, you can still be infected and can spread the disease. So wearing a mask in public kind of can increase the trust towards each other and decrease the spread of the virus. And if you are working in sales or something like this, just drop your meetings and do conference calls instead, and just try to do as many business through the screen. This kind of virus doesn't spread through the screen. So this is kind of my advice based on that. And so this graph we already took a look at here. So you can see that in Korea they managed to decrease the number of people meeting and the infecting, and so just basically putting a lot of effort into quarantining those who are already sick, and people don't go out. So they keep the quarantine regulations. So that's how it started to get flat, while you can see that in Italy it's still going strong, and also in Iran. And so same for a lot of other European countries like France, Spain, Germany, United States is also. And so what you really should be looking out for is that, like these last 2 days, if this increase is much sharper than the previous few days, then it's still going strong. It's still in this uncontained phase that you can see on this graph. So it is just going up every time it goes up stronger than it went up the last day. And so this is what what should concern you, I guess. Once it starts going down, then you can see that there is some kind of containment that was working well, that stopped the uptick. And so the thing is, you should not be panicking, but you should be rational about your attitude. So the more you are afraid of the disease and the more precautions you take, and in general society more precaution is taken by society, this will be a very big difference after days pass by, like in a month. Just halving the number of people everyone meets by canceling gathering and canceling school, you can almost decrease tenfold the number of people who will be affected by this disease. And the tenfold decrease is something that you want, because everyone compares it to the flu, and once your healthcare system is already dealing with the flu patients, you don't want additional 5,000 people in a month ending up in the ICU waiting for the respirator to get free for them. So take care of yourself, don't panic, but take rational precautions and stay healthy. And I hope to see you in the next video. Bye bye.